every variable of that enumerated variable of that object using this type of loop, and then print out that information whenever you need it. So in this way, we can try and recreate the browser's environment as realistically as possible. And then in JavaScript, you can reassign the variables for functions. So if we take a variable function name and set it to our, we take a copy of it, then define it as a new function to execute the old function and do additional work, such as print out the contents of the obfuscated code, then we can get what we need. So there have been a lot of new hooked functions that are necessary to decode these things, and several of them are time-based. So set interval is one that I'll have an example with later. And additionally, you can do this with PDFs. Dieter Stevens has created a tool where you can just pass a file on the command line and insert JavaScript into a PDF file. And then you can profile it this way and figure out what's defined in the current environment and what they contain. So the other feature of Jsunpack is the rules language. This processes all decoded content. So if a hook applies to something, then we can define a rule that looks for any of the decoded data. In this case, this is a newer media.newPlayer vulnerability for PDF files. And there's, at the top of this Yara rule in bold, you'll see decoded PDF, and there's another keyword called decoded only. This is the rule language, which basically does what it says and allows you to put filters on the rule to say that this only applies to decoded content and not to regular HTML. So there's another type of rule that is necessary to detect these things, and that's a dynamic rule. And this is JavaScript. And basically, we're creating the object which will execute once the JavaScript actually executes. So both of these are necessary because if our script contains an error, we still want to process the static content and run the Yara rule. But if the Yara rule, if the attacker assigns the media to a variable, then our static rule will never detect it. So there's an output directory with Jsunpack, and it creates various types of files. Whenever it decodes something, it'll create it according to that name. In the post-processing, when it decodes shellcode, it'll create it of that name. And with the -s option, you can save all the streams and the dgzipped and dechunked content, and those get saved as separate names. Whenever the shellcode matches a URL within the packet capture, that's a special case where you know that the client who downloaded it was actually exploited successfully. So in that case, you can determine, you have a real incident here. Malicious code was installed. And then there's various other debugging and files of that type. So by default, it only outputs malicious content. If you want to see everything, you would use the -v option. Or if you want to see the errors and additional information, use the capital -V. There's a graph mode showing the path, and this shows circled by red boxes whenever something is detected as malicious or suspicious by the rules. And this gives you some idea of the data structures that I've used. They contain a link type so that we can determine what type of detection we want to do on them. So one of the challenges I've tried to overcome with this is, of course, the infinite loops. So I put time limits on the script evaluations, and whenever it exceeds that limit, then I throw a warning. And in my experience, most of the malicious scripts are the ones that take longer. So the benign scripts typically are very quick to evaluate. There should be very few exceptions to that because they're generally assigning large amounts of data and doing heap spraying so that when the exploit is successful, it can jump to that address. But in those cases where it times out, we may not get the full decoding because it's based upon the machine being able to do that quick enough. And some of these exploits take, a minute or two to actually exploit a victim. The other thing that a lot of attackers are doing is profiling the user before they do things. And we can run every case of every version within this environment and determine which decodings belong to which version. So I'll show you an example, but these are the versions I'm currently using. And what happens is it'll evaluate the first one, and to save evaluation time, it will only evaluate the next ones if that first one didn't take too long. So basically, this is an effort to prevent it from taking several minutes to evaluate something. So this is an example of a PDF that I've included in my source code as an example. And this is a malicious file where the JavaScript uses a time-based decoding. And the set interval function basically says after 1,000 milliseconds, I want to set this variable to be x, where if it doesn't evaluate, it's still g. So the exploit here uses the annotate PDF field, and if it does evaluate, then it'll translate the get annotates function into the xet annotates function. So the problem here is we define this app.setInterval, and if you evaluate it immediately, then this will not decode correctly because it's this xet annotates function is not a valid function. So to handle this, I try to determine whether to process the hook within the immediately